ask you, what is the brain and spinal cord made out of? Now, let me tell you my natural things. People will say tissue. Okay, what is tissue? I don't know what tissue is. Okay, that's what I'll get. It's made out of muscle, it's made out of blood, it's made out of fat. We're going to find out that this entire nervous system is made out of tissue, but tissue is clusters of cells. The entire nervous system is made out of two types of cells. That's it. Just two types of cells. Let's see what they are. The entire nervous system is made up of just two types of cells: neurons, which receive and transmit information, and glial cells support the neurons. So, the entire brain, if I asked you on the test, I said, what is the brain made out of? Hopefully you guys would say just two types of cells, Amy, neurons and glial cells. There's no muscle in the brain. I mean, we can just take that as like, all right, so you know, if our brain had muscle, then of course our head would need to be able to grow. So even though the brain is an organ of the body that does grow and change, it's not made out of muscles. The entire nervous system is made up of just two types of cells: neurons, which receive and transmit information. That is the whole thing that the nervous system is responsible for, receiving and transmitting information. And then the glial cells support the neurons. So some of you say, well, what do you mean they support the neurons? Okay, now if you took Psych 2, which is all biological psychology, it's a class that would be completely just on this chapter in the textbook, and it would go into much more depth, then you would probably learn that there's many different types of glial cells, and some of the things that they do is they remove waste, and they guide embryonic development of the neurons, and they take up the empty spaces whenever neurons die, and they help nourish the neurons, and they create the myelin sheath. For the purposes of this class, we're just going to realize that glial cells, what they do is they kind of take care of the neurons to make sure that the neurons can do their very, very important job. Okay, so that is the accomplishment of Objective 2, where you wanted to be able to describe what the nervous system is made of. Let's move on to the next objective. We want to know the three basic parts of the neurons. So, here we go. The dendrites. Here's the dendrites right down here. And what they do is they carry information toward the cell. So if you remember, neurons, what their job is to receive and transmit information. So these are kind of like taking the information toward the cell. So the way I remember it is, see how there's a T in dendrite, but there's not a T in axon? You could remember T, dendrite, toward the cell. Now, the cell body maintains the cell. I had meant to have a picture here for this lecture of all the things that are inside the cell body, but I forgot to put it in. So inside the cell, what I could show you is, if you remember from your biology classes, they usually have a big circular cell, and they show you all the structures inside the cell, like the Golgi apparatus and the ribosomes and the endoplasmic reticulum and the vacuoles, and that each one of these organelles, they say, has a job. Inside all neurons is the cell body, are all those structures, and what they do is they keep the cell alive. They make sure the cell is working. So the dendrites are specialized for receiving information, taking information toward the cell. Then this axon carries information away from the cell. So if you could remember axon, A for axon, A away, A. You can remember the dendrites carry it toward, T, and the axon carries the information away. Now I wanted to let you know that for some reason this image is, the graphic got ripped here, and so there's a space here, but there shouldn't be a space. So these cells right here, there is no other body cell that looks like a neuron. What makes neurons special is that they're specialized to receive and transmit information. So no other body cell except for a nerve cell is going to have dendrites and axons. And it's for this reason that once a neuron dies, that's it. It's over. It's not going to be replaced. Now there's a few areas in the brain where now they are saying, okay, we can replace neurons. That would be in your olfactory bulbs, which is for smell. And there's big controversy about the hippocampus, that that's the area for memory. They seem to find that there may be something called neurogenesis there. But basically we're born with basically all the neurons we're going to have. We're going to add some more neurons in the first year of life, but then after the first year of life, you're not going to add much more neurons. What you're going to do is actually be pruning away the neurons. Your brain, when you're born with excess of neurons, and in the first year of life you still have an excess of neurons, and then slowly throughout life what you're doing is you're pruning, and you're getting your brain down to these are the pathways that you use. That's what's happening.